Chapter 9, Carbon and its Compounds. In this theme, students will learn the importance of carbon and some of its compounds. It is a constituent of all plants and animals. In fact, a large number of compounds are made up of carbon. It is a very versatile element. Products such as paper, wooden furniture, soaps, food items are made up of carbon as one of their elements and used extensively in daily life activities. The fuel that is used in cars and trucks is also made of carbon. Learning outcomes. After studying this chapter, students will be able to explain the term allotropy, describe different allotropes of carbon, state the properties of graphite and diamond, prepare carbon dioxide in a laboratory, describe the uses of carbon dioxide, demonstrate different reactions of carbon dioxide with lime water and litmus solutions. Important terms and their definitions. Allotropy. It is a property due to which an element exists in more than one form in the same physical state having the same chemical but different physical properties. Covalent bond. The bond formed between the atoms by sharing of electrons is called covalent bond. Catenation. The linking of identical atoms together to form long chains is called catenation. Organic compound. A carbon compound derived from living organisms. Introduction. Carbon is present in every living being and is very important element. It is present in our food that we eat in the form of carbon compounds. Carbon has many uses such as in medicines, as fuels, in clothes. In gemstones, carbon is used in the form of diamond. Carbon is represented by the symbol C and its atomic number is 6, that is, it has 6 electrons revolving around its nucleus. More than 90% of known compounds contain carbon. Occurrence of carbon. In nature, carbon is found in two states, free state as well as in combined state. Carbon in the free state. Carbon exists in the free state in the following forms. Coal. Coal is an impure form of carbon. It has been formed by the decomposition of vegetable matter of big plants and trees that got buried inside the earth millions of years ago. The wood was slowly converted to coal under the influence of high temperature and pressure. Graphite. Graphite is the crystalline form of carbon found in nature. It is a lesser pure form of carbon found in nature. It exists more abundantly than diamond. Diamond is the purest form of carbon found in nature. It is also crystalline form of carbon found in nature. Carbon in the combined state. In the combined state, carbon compounds exist in the following forms. Carbon dioxide. Carbon dioxide is present in air to the extent of 0.03% by volume. It is the main gaseous compound of carbon. Minerals. Mineral salts such as carbonate, CaCO3, limestone, marble or chalk, MgCO3, magnesite, MgCO3, CaCO3, dolomite, ZnCO3, calamine are important compounds of carbon found in nature. Natural gas and petroleum. Natural gas is an important fossil fuel. It consists of mostly methane, CH4, a carbon compound. Petroleum, another very important fossil fuel, is a liquid mixture of carbon compounds like petrol, kerosene and diesel. Petroleum and natural gas are called hydrocarbons as they consist of compounds made of only hydrogen and carbon. Living organisms. Plants and animals contain carbon compounds such as cellulose, carbohydrates, proteins, fats and vitamins. These carbon compounds constitute the important nutrients of our food. Some compounds of carbon. Allotropes of carbon. Before we start discussion about allotropes, let us know about crystalline and amorphous solids. Crystalline solids. Crystalline solids have definite geometrical forms. When these are cut or broken, the pieces obtained have sharp edges and plane surface. These solids melt at definite temperature, which is the melting point. Rock salt, common salt, sugar and alum are examples of these types of solids. Amorphous solids. Amorphous solids do not have definite geometrical forms. When these types of solids are cut or broken, the pieces obtained do not have sharp edges. These types of solids do not melt at definite temperature, but when heated, soften over a range of temperature. Glass and plastic are some of the examples of these solids. What is allotropy? The phenomena of an element existing in different physical forms which have different physical properties but have similar chemical properties is called allotropy or allotropism. These different physical forms have different physical properties but similar chemical properties are called allotropes. Carbon exists in two allotropic forms, namely the crystalline form and the amorphous form. Crystalline forms of carbon. The crystalline forms of carbon are diamond, graphite and fullerenes. Diamond. Diamond is the costliest gemstone and the hardest natural substance known. In its purest form, a diamond is a colorless, lustrous and crystalline solid. Some diamonds have different colors like tinged yellow, blue, brown, green, pink and even black. This color is due to some metallic impurities present in these diamonds. The grey or black variety of diamond is known as carbonado and bought. The beauty of diamonds depends upon the skill with which it is cut and polished. Due to rigid structure involving strong covalent bonds, the melting point of diamond is very high, which is of the order of 3500 degrees centigrade. The major source of diamonds is a region in South Africa which produces and supplies nearly 70% of the world's demand for diamond. Some places where diamond mines are found are South Africa, Siberia, Brazil and Belgium. Researchers show that to prepare small diamonds by compressing carbon under extremely high pressure and temperature. Diamonds so prepared are called synthetic or artificial diamonds. Synthetic diamonds are widely used in industry as cutting and grinding tools. The chemical properties of synthetic and natural diamonds are the same. Structure of diamond. In diamond, each carbon atom is bonded to 4 other carbon atoms. The carbon atom at the center has formed covalent bonds with 4 other carbon atoms lying at the vertices of a tetrahedron. See figure below. Each of these 4 carbon atoms are in turn bonded covalently to 4 carbon atoms in tetrahedral arrangements. Thus, the carbon atoms are held firmly in place and this results in a 3-dimensional rigid structure. The structure is so stable that it makes diamond the hardest substance. To know more, diamond is weighed in carats. The famous Kohinoor diamond weighed 186 carats. 1 carat is 200. Properties of diamond. Diamond is transparent to visible light and X-rays. Using X-rays, we can differentiate between a fake diamond and a real one. Diamond is insoluble in all solvents. It does not normally react with any chemical. It is very poor or bad conductor of heat and electricity. Diamond is the hardest naturally occurring solid. It has a density of 3.5% G by cc. It has a very high refractive index. It is because of this property that diamond sparkles. When light enters the diamond crystal, it suffers multiple total internal reflections and due to this, it sparkles. When ignited, it burns in air at 900 degrees centigrade and in oxygen at 700 degrees centigrade to give carbon dioxide. C plus O2 ignition is CO2. Uses of diamond. Black diamonds are used in making precision instruments for drilling rocks and cutting glass. Diamond dust is used for polishing other diamonds and valuable stones. The colorless diamonds are priceless gems and are used in making jewelry items. Graphite. Graphite is a black grayish opaque solid. It is soft and slippery to touch. The name graphite is derived from the Greek word graphos meaning to write. The lead used in our writing pencils is prepared by mixing graphite with clay. Graphite is mined in Jharkhand, Andhra Pradesh, Jammu and Kashmir, Odisha, Rajasthan, Tamil Nadu and Uttar Pradesh. Other than in India, it is found in Sri Lanka and Russia. In United States of America, it is mined in New York and Pennsylvania. It is artificially prepared by strongly heating coke with silica in an electric furnace. 3C coke plus SiO2 silica, heat SiC silicon carbide. SiC heat Si plus C graphite. Structure of graphite. Graphite is also a crystalline form of carbon. However, the crystal pattern of the carbon atoms in graphite differs from that of carbon atoms in diamond. It is made of flat planar layers of carbon atoms. Each layer contains hexagonal rings, and each hexagonal ring in turn consists of 6 carbon atoms. Each carbon atom is bonded to 3 other carbon atoms by covalent bonds. As carbon atoms have 4 valence electrons, so if 3 of these electrons are used in forming covalent bonds, then it leaves 1 free electron per atom of carbon. This electron is free to move within the crystal lattice. It is this fourth and loose electron that makes graphite a good conductor of electricity. The atoms in one layer are very loosely joined to the atoms in the adjacent layer. This enables layers to slip over each other. This is why graphite is soft and slippery to touch and acts as a good lubricant. Properties of graphite. Graphite is a good conductor of electricity. It is insoluble in most solvents. Graphite is a grayish-black opaque solid. It has a metallic luster. It is soft and slippery to touch. It has a density of 2.2 G by cc. It leaves a black mark when drawn across a paper. Melting point of graphite is 3700 degrees centigrade. Uses of graphite. Graphite is used to make carbon brushes in dynamos. It is used in making pencil lead. As a graphite is a good conductor of electricity and withstand high temperatures and is not easily attacked by chemicals, so it is used for making electrodes. It is used as a lubricant in fast-moving machinery parts for the reasons mentioned above. As graphite can slow down fast-moving particles, so it is used as a moderator in atomic reactors. Fullerenes. Fullerenes are a crystalline form of carbon. Fullerene was discovered in the year 1985 by 3 scientists, H. W. Kroto, R. F. Curl, and R. E. Smalley. They were awarded the Nobel Prize in Chemistry in the year 1966 for this discovery. Structure of Buckminster fullerene. A crystal lattice of fullerenes can have about 30 to 900 atoms of carbon in a molecule, for example C32, C50, C60, C70 and so on. The first fullerene C60 was artificially prepared by an American architect in 1985 by Richard Buckminster Fuller. This artificial fullerene is called Buckminster fullerene or buckyball. Each molecule of the Buckminster fullerene contains 60 atoms of carbon arranged in the form of a spherical ball consisting of 12 pentagons and 20 hexagons. Fullerenes are occurred and situated between stars, dust and in some carbon-rich rocks. Buckyball is found in soot. Properties of fullerenes. Fullerene does not conduct electricity. It is an insulator. The buckyball is a yellow crystalline solid. It is soluble in organic solvents. Some of the compounds of fullerenes act as superconductors. Amorphous forms of carbon. Unlike the crystalline form, the amorphous form of a substance contains loosely held particles. The amorphous forms of carbon are coal, charcoal, lampblack soot, gas carbon and coke. Coal. Coal is obtained when the organic matter, mainly big plants and trees, trapped deep inside the earth, decomposes under the influence of heat and pressure. Uses of coal. Coal is used for the manufacture of coal tar, which is the source for the production of many organic compounds like dyes and explosives. The most important use of coal is as a fuel. It is also used in the production of fuel gases. Coal can be converted to coke by destructive distillation. Adsorption. Adsorption is a surface phenomena and should not be confused with adsorption. It is the property by which a substance collects a thin layer of another solid, liquid or a gas on its outer surface, such as ink drops on a piece of chalk. If a few drops of ink are dropped in water and small pieces of charcoal are placed in this solution, then after about half an hour after stirring, the color of the solution of the ink fades, or the ink fades because charcoal has adsorbed the particles of ink. Such a substance like charcoal on whose surface adsorption takes place is called an adsorbent. Charcoal. The charcoal is obtained when organic matter such as wood, vegetable matter or even bones are heated in absence of air or limited supply of air in order to break bigger molecules into smaller ones. This process is called destructive distillation. During this process, the gases and the liquids having low boiling points escape, leaving behind charcoal. Therefore, when a solid organic compound is subjected to destructive distillation, charcoal is obtained. Charcoal is black in color, soft and porous. As charcoal is porous, it has a large surface area in a small volume and is therefore used as an adsorbent to adsorb gases. Depending on their sources, there are three types of charcoals: wood charcoal, bone charcoal or animal charcoal, and sugar charcoal. Wood charcoal. To get wood charcoal by heating wood in the absence or limited supply of air, wood charcoal is left as a black porous solid residue. The gases formed during this process are carbon dioxide CO2, carbon monoxide CO, methane CH4 and hydrogen H2. This mixture of gases is combustible and is known as wood gas. When wood gas is condensed, the vapors change into air and a liquid which contains carbon compounds. Physical properties of wood charcoal. Wood charcoal is grayish black in color, porous and brittle. It has a density of 1.5 G by cc. It floats on water because of its porosity. It is a bad conductor of heat and electricity. It adsorbs gases, liquids and solids. Wood charcoal is chiefly used as an adsorbent for gases because of its large surface area. This is why it is used in gas masks and for the filtration of water. Uses of wood charcoal. Wood charcoal is a better fuel than wood because its calorific value is higher than wood and its ignition temperature is lower than wood. It also causes less air pollution. Since it is a good adsorbent, so it is used in household water filters and in town or city water treatment plants to adsorb bacteria. Since it absorbs gases as well, so it is used in gas masks for military purpose and industrial purpose. Wood charcoal is used to prepare anti-gastric medicines for people suffering from indigestion and as it adsorbs gases produced in stomach. It is used in deodorants as it adsorbs foul-smelling gases. Activated charcoal. Activated charcoal is used as a catalyst to facilitate certain chemical reactions. If wood charcoal is heated at around 900 degrees centigrade in limited supply of air, activated charcoal is formed. In powdered form, it has far more surface area than that of wood charcoal. Therefore, it is more active than wood charcoal. Hydrogen reacts with chlorine very slowly, but hydrogen readily combines with chlorine adsorbed on activated charcoal in dark. Activated charcoal is also used to separate a mixture of noble gases such as a mixture of helium, argon, neon and krypton. Bone charcoal. We get bone charcoal by first boiling bones in water to remove fatty substances and then subjecting them to destructive distillation. Bone charcoal contains only 10% carbon and a high percentage of impurities like calcium phosphate and calcium carbonate. It possesses good decolorizing property and is used as a decolorizing agent, especially to decolorize cane sugar solution. Sugar charcoal. Sugar charcoal is very pure form of carbon. It is prepared by dehydrating cane sugar with concentrated sulfuric acid. The residual black carbon mass is then washed and dried. It is the purest form of amorphous carbon. It has the same uses as bone charcoal. Lamp black or soot. Lamp black, which is also called carbon black or soot, is prepared by burning hydrocarbons like oil, wax, kerosene, oil, paraffin, naphthalene or petrol in a limited supply of air. These substances burn with a smoky flame which contains a large amount of free carbon. When this smoke is allowed to cool on a surface, carbon settles down as a fine powder called lamp black or soot. The deposited soot is then scraped off the surface and used as per requirement. Kajal is prepared in homes by burning a cotton wick in mustard or coconut oil or ghee in a small earthen lamp and then cooling and collecting its smoke. Uses of lamp black. Soot is used as a filler in the rubber industry. It is used to make carbon paper and printing ribbons. Lamp black is used as a pigment and coloring matter in ink, shoe polish, etc. Soot is used in the manufacture of gunpowder. Gas carbon. During the process of destructive distillation of coal or heating of hydrocarbons at high temperatures, they decompose and carbon particles get deposited on the walls of the container. These carbon particles are collected to form gas carbon. Uses of gas carbon. Gas carbon is grayish solid having density slightly above 2 g/cc and is a good conductor of electricity. Gas carbon is used to manufacture electrodes. Coke. Coke contains about 95% carbon. It is obtained as a residue in the destructive distillation of coal. Uses of coke. Coke is a good reducing agent and is therefore used in the extraction of metals like zinc and iron. Coke is also used in the manufacture of carbon monoxide, which is also a very good reducing agent. Coke is used to manufacture fuel gases like water gas and producer gas. As coke is smokeless, so it is used as a household and industrial fuel. Chemical properties of carbon. Carbon has a great affinity for oxygen. When heated in an excess supply of oxygen forms carbon dioxide. If the supply of air is limited, carbon monoxide is formed, which is a poisonous gas. C carbon plus O2 oxygen is CO2 carbon dioxide plus heat. 2C carbon plus O2 oxygen is 2CO carbon monoxide plus heat. Carbon monoxide burns further in the air to produce carbon dioxide. 2CO plus O2 is 2CO2 plus heat. When carbon is heated with hydrogen at 500 degrees centigrade and 250 atmospheric pressure, it forms a mixture of hydrocarbons like methane, ethane, etc. The final product depends on the amount of carbon and hydrogen used. C carbon plus 2H2 hydrogen is CH4 methane. Carbon is a good reducing agent. It can reduce oxides of metals placed below zinc in the middle activity series to their corresponding metals. ZnO plus C is Zn plus CO, CuO plus C is Cu plus CO, PbO plus C is Pb plus CO, Fe2O3 plus 3C is 2Fe plus 3CO. It reduces concentrated sulfuric acid and nitric acid to form sulfur dioxide and nitrogen dioxide respectively. C plus 2H2SO4 is CO2 plus 2H2O plus 2SO2. C plus 4HNO3 is CO2 plus 2H2O plus 4NO2. Carbon in the form of white hot charcoal and coal reacts with superheated steam to form water gas. It is a mixture of carbon monoxide and hydrogen. This is also called as reduction of water. C white hot plus H2O steam is CO plus H2 water gas. Water gas is used in industry to prepare a large number of organic compounds. As both the gases CO and H2 comprising water gas are combustible, water gas is used as an industrial fuel mostly for the synthesis of ammonia. 2CO plus O2 on burning, 2CO2 plus heat. 2H2 plus O2 on burning, 2H2O plus heat. Catenation. Catenation is the binding of an element to itself through covalent bonds to form chain or ring molecules. This property of carbon of forming long chains among its own atoms is known as catenation. The chains which are formed by the combination of carbon atoms can be straight, branched or closed. This property of carbon opens the horizon to limitless possibilities of compounds of carbon. Carbon compounds derived from living organisms, plants and animals are called organic compounds. Examples of organic compounds are coal, natural gas, petroleum products, starch, sugar, glucose, vegetable oils and so on. But some compounds of carbon like carbon dioxide, carbon monoxide, carbonates, carbides, cyanides and so on are not derived from living things. Such compounds come under the group of inorganic compounds. Characteristics of organic compounds. They can exist in all the three states, solid, liquid and gas. Organic compounds are covalent compounds formed by the sharing of electrons. They are insoluble in water but soluble in organic solvents like benzene and toluene. They have low boiling and melting points. Organic compounds are flammable, volatile and considered as poor conductors of electricity. Hydrocarbons. Hydrocarbons are the compounds of hydrogen and carbon, both the elements combined in various properties, giving rise to a large number of hydrocarbons like methane, ethane, butane, benzene, etc. Hydrocarbons are of two types, saturated hydrocarbons and unsaturated hydrocarbons. Saturated hydrocarbons. In saturated hydrocarbons, the carbon atoms are connected only by single bonds. Saturated hydrocarbons are grouped under the general name alkanenes or paraffins. The general formula for alkanenes is CnH2n plus 2, where N is the number of carbon atoms in a molecule of the alkane. Unsaturated hydrocarbons. In unsaturated hydrocarbons, the adjacent carbon atoms are joined by double or triple bonds. Difference between organic and inorganic compounds. Organic compounds, characteristic odors and colors, highly volatile, low melting and boiling point, insoluble in water, dissolve in organic solvents like benzene, carbon tetrachloride, chloroform and pyridine, generally inflammable, covalent bonds present in the molecules of organic compounds. Inorganic compounds, usually colorless and mostly odorless, non-volatile, boiling point and melting point are relatively high, soluble in water, insoluble in organic solvents, generally non-inflammable, ionic bonds present in the molecules or inorganic compounds. Laboratory preparation of carbon dioxide. In a laboratory, carbon dioxide gas is prepared by the action of dilute hydrochloric acid on marble chips, calcium carbonate. Let us understand the laboratory preparation of carbon dioxide by performing an activity. Place a few marble chips in a conical flask. Fit a cork with 2 holes on the mouth of the conical flask. Put a thistle funnel in one of the holes of the cork and one end of a delivery tube in the other hole. Insert the other end of the delivery tube into the gas jar, see figure below. Pour dilute hydrochloric acid into the conical flask through a thistle funnel. Hydrochloric acid reacts with marble chips to liberate carbon dioxide, which gets collected in the gas jar by passing through the delivery tube. The reaction can be represented as CaCO3 plus 2HCl, calcium carbonate plus hydrochloric acid is CaCl2, calcium chloride plus H2O, water plus CO2, carbon dioxide.
To know more, soda water and fizzy drinks contain carbon dioxide gas dissolved in water under pressure. When these bottles are opened, we see carbon dioxide gas coming out with a fizz.
How to test that the gas being produced is carbon dioxide? We can test carbon dioxide gas by passing it through lime water. Carbon dioxide reacts with lime water to form a white insoluble solid called calcium carbonate. This gives the solution a milky appearance. The change can be represented as CaOH2 plus CaCO3 lime water calcium carbonate insoluble plus H2O water CO2 carbon dioxide. Other methods of preparation of carbon dioxide. Carbon dioxide gas can be prepared by various methods. Some of them are discussed here. By the reaction between baking soda and vinegar. Baking soda or sodium bicarbonate reacts with vinegar, acetic acid to produce carbon dioxide gas. NaHCO3 plus CH3COOH is CH3COO Na plus CO2 plus H2O. By burning carbon compounds in sufficient supply of air. Compounds containing carbon like methane CH4 burn in sufficient supply of air to form carbon dioxide gas. CH4 plus 2O2 is CO2 plus 2H2O. By burning carbon in sufficient supply of air, when carbon is burnt in sufficient supply of air or oxygen, carbon dioxide gas is formed. C carbon plus O2 oxygen is CO2 carbon dioxide. Physical properties of carbon dioxide. Carbon dioxide shows the following physical properties. Carbon dioxide is a gas at room temperature. It has no color and no odor. It has a pleasant taste. It is slightly soluble in water. It is heavier than air. It shows sublimation as solid carbon dioxide directly changes into gaseous carbon dioxide gas on heating. Chemical properties of carbon dioxide. Carbon dioxide shows the following chemical properties. Carbon dioxide gas is acidic in nature. Reaction with bases. Carbon dioxide gas reacts with bases like sodium hydroxide NaOH to form salt and water. 2NaOH plus CO2 is Na2CO3 plus H2O. Reaction with water. Carbon dioxide gas on mixing with water forms a very weak acid called carbonic acid. H2O plus CO2 is H2CO3. Carbonic acid turns blue litmus only purplish red, showing it is a weak acid. Carbon dioxide is a non-supporter of combustion. Carbon dioxide gas neither burns nor supports combustion. If we bring a burning matchstick near the mouth of a gas jar containing carbon dioxide, it extinguishes. The property of carbon dioxide is also used in fire extinguisher. Reaction with lime water. On passing carbon dioxide gas through a clear solution of lime water, CaOH2, we notice that lime water turns milky. The reaction can be represented as CaOH2 lime water plus CO2 carbon dioxide is CaCO3 calcium carbonate white precipitate plus H2O water. The milkiness is due to the formation of a white precipitate of calcium carbonate. When we pass carbon dioxide gas in excess, we will see that the solution turns colorless. This is because of the formation of a new substance called calcium bicarbonate which dissolves in the solution. The reaction can be represented as CaCO3 calcium carbonate plus H2O water plus CO2 carbon dioxide is CaHCO32 calcium bicarbonate clear. Uses of carbon dioxide. Carbon dioxide gas has the following uses. Carbon dioxide is used by green plants for photosynthesis. Carbon dioxide and nitrous oxide acts as an anesthesia. It is used as a raw material in the manufacture of certain chemicals like baking soda, NaHCO3 and washing soda, Na2CO3, 10H2O. It is used in making aerated drinks like soda water and soft drinks as it gives a pleasant tangy taste. It is used as a refrigerant in the form of dry ice to deep freeze foods. It is used in fire extinguishers as it is a non-supporter of combustion. Properties of carbon monoxide. Physical properties. Carbon monoxide is a colorless, odorless, tasteless, non-corrosive, highly poisonous gas of about the same density as that of air. It is very flammable and burns in air with bright blue flame. Its melting point is minus 205.0 degrees centigrade and boiling point is minus 191.5 degrees centigrade. It is insoluble in water above 70 degrees centigrade. Chemical properties. Carbon monoxide is an unsaturated compound which unites with oxygen either free or combined to form carbon dioxide and also with various other substances under suitable conditions. Carbon monoxide can reduce compounds containing oxygen not only at high temperature as in metallurgy but also in some cases at low temperatures. By the interaction of lime and carbon monoxide between 350 degrees centigrade and 400 degrees centigrade, considerable quantities of methane, ethylene and hydrogen are formed by the following reactions. 2CO plus CaOH2 is HCOO2Ca is COO2Ca plus H2O. 2HCOO2Ca plus CaO is 3CaCO3 plus CH4. 4HCOO2 plus 2CaO is 6CaCO3 plus C2H4 plus 2H2. Carbon monoxide also reacts with sodium methoxide and its homologous at 160 degrees centigrade to produce the sodium salt of the corresponding carboxylic acid. CO plus CH3 ONA is CH3 minus COONA. Uses of carbon monoxide. Carbon monoxide is a very important industrial compound in the form of producer gas or water gas. It is widely used as a fuel in industrial operations. This gas is also an effective reducing agent. For example, when carbon monoxide is passed over hot iron oxides, the oxides are reduced to metallic iron while the carbon monoxide is oxidized to form carbon dioxide. It is used in the Fischer-Tropsch process for the manufacture of hydrocarbons and their oxygen derivatives from a combination of hydrogen and carbon monoxide. Carbon monoxide also reacts with certain metals, especially iron, cobalt and nickel, to form compounds known as carbonyls. Harmful effects of carbon monoxide. Carbon monoxide is a major pollutant. It is a gas produced by incomplete burning of fuels like petrol, diesel, wood, kerosene, coal, etc. A fuel may not burn completely if the supply of air is insufficient. Carbon monoxide is mainly produced by burning fuels in industries, automobiles, factories, etc. It is a very poisonous gas. When inhaled, it combines with the hemoglobin present in the blood and lowers the amount of oxygen that enters the blood. It slows our reflexes, and too much carbon monoxide can cause death. Fast track chapter at a glance. Carbon is the major constituent of the complex molecules that control reproduction in organisms. Carbon atom has R electrons in its outer shell. It always completes its octet by sharing electrons and therefore forms covalent bonds. In nature, carbon is found in free as well as combined state. In free state, carbon is mainly found as diamond, graphite and coal. In combined state, carbon compounds exist in all the three states, that is solid, liquid and gaseous state. The crystalline forms of carbon are diamond, graphite and fullerenes. Diamond is the purest form of carbon. It is the hardest naturally occurring substance. Graphite is a grayish-black opaque solid. It is a good conductor of electricity. The first fullerene was prepared artificially in year 1985 by Richard Buckminster, an American architect. The amorphous forms of carbon are coal, gas, carbon, coke and lamp black. Coal is formed when organic matter is subjected to decomposition under high pressure and temperature inside the earth. Lamp black, also called carbon black or soot, is formed by burning hydrocarbons like oil, wax, naphthalene and so on in a limited supply of air. Gas carbon is prepared by the destructive distillation of coal or heating of hydrocarbons at high temperatures. Coke is obtained as a residue during the destructive distillation of coal. Carbon atoms show a unique property of forming long chains among its own atoms. Carbon compounds derived from living organisms are called organic compounds. Hydrocarbons are the compounds of hydrogen and carbon. Hydrocarbons are of two types, saturated and unsaturated. Carbon dioxide CO2 is a vital gas. It is required for photosynthesis by green plants. In a laboratory, carbon dioxide gas is prepared by the action of dilute hydrochloric acid on marble chips calcium carbonate. Carbon dioxide gas is acidic in nature. Carbon dioxide turns lime water milky. Carbon monoxide is a major pollutant.